In this lesson, we're going to go over angles on similar triangles. So similar triangles. Similar triangles have congruent angles, but they are not the same size. They are the same shape. If two corresponding angles in a triangle are congruent, that means that the triangles are similar. The third angle will be the same in both triangles. So here is an example of that. So angle A on this triangle and angle A on the first copy. I have two lines here and two lines here. If the symbols are the same on both, that means they are the same measurement. It doesn't give me the measurement number, but if the symbols, so like two lines here, that means this is the same as the other two lines. Angle B has 3 lines on the first one. Angle B has 3 lines on the first copy. So angle B is the same measurement. They are congruent. Angle A has the same measurement. Those are congruent. So knowing that 2 on the same spot have the same measurement, angle C will automatically be the same. So these two triangles are similar. An easy way, so angle right here, AB, or side AB, side AB. Side AC, side AC, BC, BC. So color coding it also helps with the orientation. So sometimes you will see these triangles, one of them might be spun around a different way, and it might still be similar. So let's look at some examples we have here. The first one up here, we have, let's go long side as the top, long side as the top, and short side, short side. Okay. I know that this measurement is 67 on the top, 67, 67. This measurement I don't have here, and this measurement I don't have here. But something I could do is take this measurement, insert it here, and see if it adds up to 180, because remember, all the inside angles of a triangle should add up to 180. So 67 plus 65 plus 48, that does equal 180. So these two triangles are similar, because if this angle is 48, that means this angle is 65. So this is, yes, it's similar. Now let's look at the one below it. So again, we can go ahead and do some highlighting. So the short side next to an 80, I have a short side next to an 80. Long side here, long side here. Okay, so 80, 80. I don't have this measurement, but I have 60 here. 30, and I don't have a measurement. So again, if I take 30 and put it here, if these three sides add up to 180, it is indeed similar. So 80 plus 60 plus 30 equals 170. So this side, this angle is not 30, and this angle would not be 60. So no, this one is not similar. Now let's look at this example over here on the top left-hand side. So look, when we go to color these, right, so I have 75 and 75 here. I have a 55 on the short side, and I don't have a measurement on the short side. So this side, if I color this side, would match this side on this triangle. They spun the second triangle. So 75 down to the point would be here, 75 down to the point would be this side, and if I want to continue to color it, this would be that side. So now let's look at this. If I have 75 here, I don't have a measurement here. On this one, it's 55. I have 50 here, and I don't have a measurement here. So if I input 55 onto this one, add it up, and if it equals 80, those are similar. If it does not, it is not. Sorry, I'm at 180. So 50 plus 75 plus 55 equals 180. So yes, those two triangles are similar. Now look at this last example. They got really tricky here, but I want you to pay attention to what information they gave us. So we know that this side with the 61 to the point is here. On the smaller triangle, it's this side from the 61 to a smaller point. Well, this is also, this angle and this angle are going to be, if you remember from a couple lessons ago, vertical angles. So these two are automatically going to have the same measurement. So if this angle is 61, this angle 61, these two are vertical angles, they have the same measurement. So if two of the angles are the same, the third one has to be the same also. So this triangle then is, or these two triangles are similar. So similar figures are the same shape but are not the same size. Their corresponding side lengths are proportional. So they are going to be proportional. So if this triangle here and this triangle are proportional, maybe I take this triangle, I times it by 1/2, right? It shrinks smaller. So the angles are going to be the same measurement, but the side lengths will all be at half size. So there is a constant ratio called a scale factor between the corresponding sides. So that was like the example I just said about timesing it by 1/2. The second triangle would shrink smaller, but it would all be in the same proportions, just smaller. So write an example proportion between the corresponding sides on this one right here. So this is where highlighting sides really comes in handy. So here is this side with 2 lines to 3 lines, 2 lines to 3 lines on that measurement. The bottom, so 3 at corner B to 1 at C, 3 at corner E to 1 at F, and then the last side here and here. Okay, so here are some examples of setting up the proportion with similar sides. So the side on the big triangle over the side on the little triangle is equal to the side on the big triangle that correlates with the side, or corresponds with the side on the little triangle. Same thing here. I color-coded just so you can kind of see the angle relationships. So right here, blue side from the big triangle over the blue side on the little triangle equals the green side on the big triangle over the green side on the little triangle. So here is an example. We need to find x, and x is right here. Look at the angle measurements, okay? And this is where I would go ahead and just highlight sides. So big sides are gonna go ahead and correlate there. 2 lines to 3 lines on this side, and that is all I need. So I can go ahead and set up a proportion. So maybe I want to call this triangle A and triangle B. And maybe I want to go A over B when I set up the sides, right? So I'm going to go 6 over 4, because 6 is that side on the big triangle, 4 is that side on the little triangle. 2, again, the side on the big triangle, so it would be 9 over x equals 9 over x. So one way I can do this is I can look at it and go, okay, from 6 to 9, what do I times by, or how did I get there? And then figure out from 4 to do that to the same from 4 to get x. Or I can set up a proportion this way. Go ahead and go like this, cross multiply and divide to solve. So if I set up the little butterfly, I'm going to go 4 times 9 equals 6 times x. 4 times 9 gives me 36 times 6x. 6 times x, I need to get x by itself, so the inverse operation is to divide. Divide by 6, divide by 6, leaving me just x. 6 goes into 36 6 times, so x equals 6. Same thing on this figure. Go ahead and we can color code corresponding sides and then set up a proportion. So again, I'm gonna call this figure A and figure B. So let's go, we can go B over A this time. Doesn't really matter. This over here is just my key that helps me remember what to do. So if I go B over A, so let's go, the X side is the 10 on the A side, and 3.75 is 5 on the A figure. So once I set that up, cross multiply and divide. So once I do that, it gets 10 times 3.75 equals x times 5. Gives me 5x equals, when I do the math here, I get 37.5. I want to get x by itself, so I'm going to go ahead and divide by 5, and x equals 7.5. Okay, so in looking at this example, right, so figure 1 and figure 2 are similar. Which proportion must be true? So I highlighted the corresponding sides. Remember, this is figure 1 and this is figure 2 here. So that also plays an important part when we look at our options. So let's see here. We have A, B right here over EF, yes. So this proportion right here is 1 over 2. Now let's look at GH, which is on figure 2. So this one would not be an option, because if the first proportion is figure 1 over figure 2, the second proportion must be figure 1 over figure 2. So let's look at option B. I have AB, which is figure 1, over EF, which is figure 2. Okay, those are both green sides. I have CD, which is figure 1, blue, over FG, which is figure 2, but it's red. So this one could not be it. Option C says AB, which is on figure 1 in green, over GF. GF is figure 2, but it's red. So this one could not be it. D, I have figure AB, which is figure 1 in green, over EF, which is figure 2 in green. Second proportion, I have CD, which is blue in figure 1, over GH, which is blue in figure 2. So D would be the correct proportion. So the sides must match up and what figure it matches up on. So if the first proportion has figure 1 in the top, the second proportion has to have figure 1 on the top.